This video covers the most common issues users encounter in Sefaira for Revit and how to solve them. The first most common issue is too many planes in the model. And the first thing to check here is the Sefaira view. The error that you might encounter might look like either of these. The analysis could time out, like the error on the left, or you might get a specific plane count error, like the one on the right, saying that you have too many total planes, or specifically too many glazing or shading planes. The first thing to check when you see a total plane count error is that you're in the correct analysis view. So if you're doing daylighting analysis, then you need to be in this view, the daylight analysis view. But if you're doing energy analysis, you need to be in the energy analysis view, because this one contains substantially fewer planes. To do energy analysis while in the daylighting view, you will likely get a plane count error like the one that we saw. One other thing to check here is that the analysis type that you've selected in Sefaira matches the view that you've selected. So if you've selected daylighting view, make sure that you've selected a daylight analysis mode in Sefaira, and vice versa for energy. The second most common error is too many glazing planes specifically. And there are two common causes for this. One is the type of window family that you have, particularly custom window families. And two, it could be the curtain wall grids are cutting through the glazing. Let's talk about windows first, and talk briefly about window simplification in Revit. So as this knowledge base article illustrates, Sefaira automatically takes a pass at simplifying most window types within Revit. So a typical fixed window, for instance, number 2 in that diagram, would be simplified to 4 planes in Sefaira. However, that simplification does not apply to custom window families in Revit. And in many cases, those custom families will have hundreds of planes that Sefaira is trying to interpret, and that can quickly drive up your plane count. One solution for that is to download the suggested Revit window, which you can find in this knowledge base article, and use the Sefaira window family in place of the custom window families that you've modeled. If your building is very large and you actually have more than 1,500 windows in your building, you may want to model portions of your building at a time. And for a detailed description of that workaround, you can find this article in the knowledge base. The other common cause of too many glazing planes in the model is curtain walls. And here's a model that has a curtain wall system in it. And Sefaira does try to simplify curtain walls similar to the way it simplifies individual windows by stitching together the individual panes. However, if the curtain wall mullion is modeled so that it cuts through the glass and the individual panes are therefore separated by the thickness of that mullion, Sefaira won't be able to stitch them together, and rather than one big sheet of glass representing that curtain wall, you'll end up with many individual panes of glass. Is to resolve that issue. One is to remove the curtain wall grid entirely from your model. You can do that by selecting the curtain wall and then adjusting the properties in the Edit Type dialog. Or you can edit the mullions so that they do not cut through the glass. And in that case, you simply select the mullion, Edit Type, and what you want is for the offset to match the thickness of the mullion. So in this case, 150. You'll see that brought the mullions out in front of the glass. They no longer cut through, and Sefaira will be able to stitch those panes together. A third common error is seeing daylighting on ground planes in your model. And the solution to this is to simply tag those planes as ignored. The problem will manifest itself like this. In this model, you can see that there's an exterior plane highlighted in red here, and daylight is showing up on it. Obviously, that is also then throwing off our proportions and any of our numeric analysis results. Fortunately, the solution to that issue is very straightforward. You simply need to tag any exterior elements as ignored for Sefaira. So in this case, we have that floor plate that was causing the problem. We simply go to the Properties panel and click Ignore for Sefaira and Apply, and then it will no longer be regarded as a floor plate for daylighting analysis. Common issue number 4 is simply getting no results. And the first thing to check for here is that you have a roof in your model. The error could look like a timeout message like you see on the left, or it just analyzes perpetually and does not complete. Believe it or not, the most common culprit of that error is that you have no roof in your model, and that what you think is a roof has actually been modeled as a floor element. One very fast way to check this is by looking at one of the Sefaira energy or daylight analysis, where we've color-coded the roof components, and you can see very quickly here that this component that should be a roof is in fact modeled as a floor. We'd want to remove that and model it as a roof. This next one isn't so much an error per se as the results maybe just don't make sense. The energy results will look wrong. Very common things to check here are the window and wall orientations and the function type of walls and windows. What do I mean by results look wrong? Well, maybe you're getting a lot of solar gain through an orientation where you don't have a lot of glass, or you're getting a lot more wall conduction than you would expect to see in your model. That would be a good flag to double check your model. So one common thing that can throw off your heat gains and losses is if you have interior walls and windows accidentally modeled as an exterior wall or window. And if that's the case, Sefaira thinks it's exterior, therefore it is receiving and losing heat to the exterior of the building, and you'll be getting heat gains and heat losses through those interior elements. The way to check this is to go to the Sefaira exterior walls view, and if you see interior walls in your exterior wall view, like I do here, we will want to change that. So we can select those, go to Edit Type, and change the function type from exterior to interior. So make sure all of your interior walls and windows have an interior function type. The thing that you should see in this view is literally your exterior envelope. The next most common thing that can throw off those gains and losses is if you have orientations of walls and windows that are incorrect. And the way to check that is in Plan View. And I have a couple windows in Plan View here that I know are facing the wrong way. Let's compare this with one that's facing correct. You'll see when you select the window a couple arrows. Those arrows should be toward the exterior. And you can see there's a couple windows here that are facing the wrong way around. Sefaira thinks that these windows, in this case, are facing south instead of north, and therefore the solar gains are going to be completely different than if they were facing the correct direction. So the change is easy. You simply click those arrows to flip it back the other way. You can do the same thing for walls and any other element of the facade, such as curtain walls. The last common error is that daylight through glazed doors does not seem correct to you. And first we're going to talk a little bit about how doors are interpreted in Sefaira, and then give a workaround for this problem. The symptom of the problem might look something like this. You can see these two arrows are pointing to glazed doors on the bottom floor. And you can see by the daylight results in those rooms that a lot more light seems to be coming through those doors than is coming through a similarly sized window directly to the right of it. And this has to do with how Sefaira is interpreting doors for energy and daylight analysis. For energy models, door families are simply discarded and replaced with opaque wall. And this is common practice in energy modeling. For daylighting analysis, the opaque portion of the door is maintained, but the glazing is discarded entirely. So it's as if there was no glass in my glazed door. And therefore, the daylight is not reduced based on the VLT, the visible light transmittance of the glass, like it would be through a window. And if a space has a lot of glazed doors in it, this simplification might not be acceptable to you, especially for luminance studies, because it's going to overstate the amount of daylight that's coming through those doors. One workaround to address that daylight issue is to convert your door families into window families. And for step-by-step instructions on how to do that, search for this article in the Sefaira knowledge base, Doors Sefaira in Revit, which will walk you through how to change a door into a window family. Keep in mind that the downside of this is that it will affect any door schedules or tags that you have set up in your Revit model. And finally, this isn't really an error, but it is something folks encounter a lot. There are a number of elements that are currently not supported in Sefaira for Revit. Those include conceptual mass elements, model and place components, adaptive components, sloped floors, or sloped walls. For an updated list or more information on any of these, you can search Sefaira's knowledge base for the article Sefaira for Revit Known Issues. And that's it. Those are the most common issues that we see in Sefaira for Revit and how to address them.